Hello everyone, welcome back to new session. So in today's session, we will discuss about address resolution protocol. Address resolution protocol. So what is the use of this address resolution protocol? So in previous session, we discussed about ping, packet internet grouper. So what is the purpose of this protocol? This command utility? The ping purpose is to check the network connectivity, right? To check the whether destination is available or not. So how it will check? The ping command uses ICMP messages, right? ICMP messages. But to send these ICMP messages, what actually PC required? So now we will understand that. Okay, first we will understand. Okay, for example, I have two computers, PC1 and PC2. PC1 and PC2 both are connected to each other through cross cable. PC1 IP address is 10.0.0.1. PC2 IP address is 10.0.0.2. And PC1 MAC address is just for example, I am taking AA, and PC2 MAC address is BP. IP address is a logical address and MAC address is physical address. So every PC has two addresses, right? One is the logical address, one is the MAC address. But what is the use of this MAC address? How this MAC address will help to us? So we already have a IP address, right? So we generally communicating in the network, we generally communicating with any system, either using IP address or either using domain name. For example, if you want to access Google, how we are accessing Google? Just simply open the browser, and in the browser we will type www.google.com. This is the domain name, this is the host name. Or if you know the IP address of Google server, we can also enter IP address in the browser. So these are the methods, right? Whenever we are going to access any device, we usually use either IP or host name, domain name, but we don't use MAC address. But internally, system use MAC address. Without MAC address, system cannot forward any message to destination in the same network, in the same LAN. I will give you one example to understand how ARP works clearly. What is the need of the ARP? Okay, I will give one small example. For example, this is one house. This is another house. Both are same area. So in the, for example, this is the house number one, house one. This is the house number two. In the house number one, the person 10.0.0.1 is living. In the house number two, the person 10.0.0.2 is living. For example, if this person one, this 10.0.0.1 person, if this person one wants to send some wants to send some post to person two, what person one required? Generally, whenever we are sending any post, whenever we are doing any courier, so actually what we required? So we required to address and from address, right? In the to address, we should mention person name, receiver name, and also we required receiver house number, and we required pin code. These three mandatory. Same way in the from also, we required name, house number, and pin code. Without this house number, the post cannot be delivered, right? Without house number, this person cannot send post to this person, right? Same here, IP address is nothing but name, person name, MAC address is nothing but house number. Just assume like that. Just imagine like that. Just consider like that. In network also, whenever PC is sending data to another PC in the same network, in the local network, the source PC required destination PC MAC address. Means if sending PC required destination PC MAC address. If sending PC doesn't know destination PC MAC address, sending PC cannot forward packet. So generally here, yesterday we have discussed ping, right? So what is the command? When you run ping in the system, for example, ping 10.0.0.2. This is the PC2 IP address. So which means what? What is the meaning of this command? When you run this command in the PC1, what happened? PC1 will send ICMP message, right? Yesterday we already discussed ICMP message type is 8, request message. But how it will send the request message? How it will send request message? So it will send one ICMP request message, right? ICMP request message. But when it is sending ICMP request, this PC add source IP, destination IP, source MAC address, destination MAC address, right? Same thing, right? Whenever we are sending any post, we need to mention to address and from address, right? In the to address is nothing but what? Destination, receiver information. From means what? Source information. This is from. This is to. This is the source. Source is nothing but from. Destination nothing but to. So when this person 10.001 person, when 10.001 person sending data to 10.002, 10.001 person need 10.002 MAC address, house number. But how PC1 will get to know? PC1, this person already know IP address 10.002. See here, we already entered ping 10.002, which means PC1 already knows about destination IP, but PC1 doesn't know what is the MAC address. To send this ICMP packet, the first this PC prepares some data like a pack. This is called packet. So it is ICMP request. In ICMP request, it will add source IP and destination IP. One second, I will write clearly. PC1, PC2. So both are directly connected. PC1 IP address 10.0.0.1, PC2 IP address 10.0.0.2, PC1 MAC address AA, PC2 MAC address BB. So now I am sending ping packet. Okay. So command is ping 10.0.0.2. This is the command, right? What is the purpose of this command? To check the connectivity. How it will check the connectivity? By sending ICMP request message, right? And then destination PC sends ICMP response message, right? But how it will send the request message? This is also one kind of data, right? So here to send this ICMP request packet, first to this PC prepare one packet. Packet is nothing but just some data here, ICMP request. So here it will add source IP. Source IP is 10.0.0.1. Destination IP 10.0.0.2. And it will also add source MAC address and destination MAC address. This is the source IP. This is the destination IP. And also required source MAC address and destination MAC address. Without this information, PC cannot forward. So here IP is nothing but person name, okay, right? And the MAC address is nothing but house number. So PC1 already knows. PC1 already knows its MAC address, local MAC address. Local MAC address is what? AA. This is the source MAC address. But what is the destination MAC address? This PC doesn't know. PC1 doesn't know destination MAC because we have given IP address here, ping 10.002, which means we are giving destination IP to PC. So PC knows about destination IP, but PC1 doesn't know what is the MAC address. Without knowing MAC address, PC cannot forward this ICMP message. Any message, not only ICMP, any message PC cannot forward. So here MAC address is very, very important. It's like a house number. Right? Whenever you are sending any post to any person, we should mention the house number, right? So generally, whenever you are giving any order in Amazon or Flipkart, we should mention our house number. Without house number, what happen? Your order will not accept, right? Because of delivery boy cannot deliver your product, right? Same thing here also in the network also. The MAC address is very, very important. This MAC address works only within the LAN. Whenever one PC or whenever one device needs to communicate to another device, the source device required destination PC MAC address. If source PC doesn't know destination PC MAC address, source PC cannot forward data. So here my question is, how this source PC will find out MAC address, receiver MAC address. So here what happened, before sending this packet, before sending this ICMP packet, the first PC1 prepare this ICMP packet without destination MAC address, and this ICMP packet would be stored in the buffer. Okay, first it will store in its buffer, and first it will check, first it will send the ARP message to find out the MAC address. So ARP is full form address resolution protocol. The main purpose of ARP is to find out the destination MAC address. Sender already knows about IP address, destination IP, 10.002. But sender doesn't know what is the MAC address of 10.002. Right. So here what happened, before sending this ICMP packet, before sending this ping request, right, first PC sends one ARP request. It will automatically happens inside internally. So first PC sends one ARP request. So how it will send ARP request? ARP request is also one kind of message. This is also message, right? But PC will automatically generate. Okay. But how it will generate ARP request? So ARP request, like so ARP request, the data is ARP request. Source IP is 10.0.0.1. Destination IP is 10.0.0.2. The source MAC address is A, but what is the destination MAC address in the ARP request? The destination MAC address is all Fs. This is the broadcast MAC address. This is what? Broadcast MAC address. This is ARP request. The ARP request meaning is nothing but PC1 is asking everyone who has 10.002, please give me your MAC address. Like that. For example, in your network, in your LAN, if you have a 50 computers, okay, PC1, PC2, PC3, PC4, like that. For example, PC1 wants to communicate with the PC50, but PC1 doesn't know MAC address of PC50. Then what happened? PC1 is asking everyone. PC1 is sending ARP request. Who has 10.002? Please give me your MAC address, like that. That is the broadcast message. We already discussed, right, in IP address class. What are the communication types? Communication types are unicast communication, broadcast communication, and multicast communication. Broadcast communication example, this one, ARP is the example of broadcast communication. PC will automatically sends ARP request. ARP request is the broadcast message. Means PC is asking everyone who has 10.002, please give me your MAC address. I have some data I need to send to you, like that. That is the meaning of ARP request. But here what is the broadcast MAC address? The broadcast MAC address is FFFF:/FFFF:/FFFF. Remember this MAC address. Very, very important. This is broadcast MAC address. Right? So PC1 sends ARP request. Now PC2 will respond. Which response? ARP reply. PC2 sends ARP reply. ARP reply. PC2 sends ARP reply directly to PC1. So here, what is the message? Like here, ARP reply. In ARP reply, source IP. ARP reply, source IP 10.0.0.2. Destination IP 10.0.0.1. Source MAC address BB. Destination MAC address AA. This is ARP reply. This ARP reply is unicast message. Which message? Unicast. Unicast message means one-to-one message. See here, PC2 is directly sending response to PC1. Hey PC1, I am the PC2. This is my MAC address, like that. PC2 will not send the response to all the other computers. PC2 will directly send response to PC1 only. This is unicast message, one-to-one message. So ARP request is the broadcast message. ARP reply is the unicast message. After getting ARP response from PC2, first PC1 store that MAC address in the ARP table. Every PC maintains the ARP table. In every computer we have ARP table. Remember this point, very, very important. Every PC, every device, not only PC, every device maintains ARP table. In ARP table, first it will store what is the IP 10.0.0.2 and what is the MAC address BB, like that. First it will store in ARP table. After that, see, this is the ping packet, right? Ping packet is still in buffer, right? Now it will fulfill with the destination MAC address. So what is the destination MAC address now? BB, and it will forward to the PC2, and PC2 will send the ICMP response. This is how communication happens. ARP is very, very important protocol. This is the first protocol involved in the communication. So the ARP main purpose is to find out the MAC address of destination. But ARP works within the LAN. Remember this point, within the network only. ARP doesn't work between the different networks. You will see these all things practically, don't worry. This is the only theory concept. But ARP is very, very important. Before sending this ICMP packet, first PC send the ARP request. But not every time, only for the first time only. See here, PC1 got the ARP request and stored here, right? Again, PC1 wants to send the another message to PC2. That time it will not send because it has already MAC address in the ARP table. For the first time only, whenever sending PC doesn't know destination PC MAC address, not a first time, whenever PC sends data to another PC in the same network, if source PC doesn't know destination PC MAC address, then it will send the ARP request. Simple thing. So now, see here. So ARP, right? Address Resolution Protocol. How ARP works here? So whenever a PC needs to send data to another PC on the same network, the source PC required destination PC MAC address. If source PC doesn't know destination PC MAC address, it sends ARP request. And if destination PC is available, it sends ARP reply. If destination PC is not available, we can't get the ARP response. Okay, remember this point. Okay, and after receiving ARP replay, the source PC store that MAC address in ARP table. How to see ARP table? ARP table command is to see the ARP table command is ARP space -A. Now see here, I will show you in my computer. First to go to command prompt, CMD ARP space -A. See, this is ARP table. This is ARP table. PC stores ARP table. Remember this point. The command is ARP space -A. So ARP messages. ARP request, ARP reply. ARP request is a broadcast message and ARP reply is unicast message. Next, and ARP request, broadcast message, right? So what is the broadcast address? FFFF colon, FFFF colon, FFFF. Total 12 EPS. This is the broadcast MAC address. So in IP address we have both, right? Unicast IP address and multicast IP address, right? Same way here also in IP address we have unicast MAC address, broadcast unicast IP, broadcast IP and multicast IP. Same way in the MAC address also we have unicast MAC address, broadcast MAC address and multicast MAC address. Remember this point, very important. Unicast MAC address nothing but on every network card we have a MAC address, right? That is a unicast MAC address. And what is the broadcast MAC address? Broadcast MAC address nothing but this one. This is the broadcast MAC address. But what is the multicast MAC address? Very simple here. We can easily remember here. We can easily recognize MAC address. So in IP address, we have a multicast MAC address, multicast IP, right? So how to identify the multicast IP address? Class D IPs are multicast IPs, right? Class D IPs. What is the class D range? Class D range is 224 to 239. So any IP address starting with the 224 and in between 224 and 239, that is like a multicast IP address. Same way, multicast MAC address nothing but multicast MAC address always start from 01:005E. This is the starting numbers 01:005E. Same like IP address 224 to 239. If you see any number in between 224 and 239, that is multicast, right? Same way here 01:005E. If you see the MAC address starting with 01:005E, we can easily understand that is what? That is the multicast MAC address. Multicast MAC address. This is about ARP. ARP is very important protocol. Please keep in your mind. In ARP, we have different types of ARPs. So we have ARP and also we have proxy ARP and also we have GRP. We have three types of ARPs. Inverse ARPs also is that is not using nowadays. That is a outdated protocol. Inverse ARP. Don't think about inverse ARP. But these three ARPs are very important. We should be very clear in these three ARP types. Proxy ARP and GR we will discuss in upcoming classes. The first understand normal ARP. That's all guys, this is today session. So if you have any doubt, if you have any query, please send your queries in Q&A session or in comment section. Okay, I will definitely respond. Thank you.